In question 2 we want to prove a derivative. We want to find out the derivative of 1 over x. That would be our derivative that we're looking for, and we want to use this formula that the derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now, first of all, let's actually have a look on a graph. Why would a derivative be equal to a limit? What is the relationship between the two? So let's draw a graph over here and we will prove it. So we have an xy axis, and let's say this would be our derivative. Actually, this would be our graph. First, our graph. Okay, and we want to find out the derivative at a certain point. Well, let's say the derivative we want to find out at this point. How does the function change when we increase x by 1 unit? Well, how can we find that? Remember, the derivative shows the rate of change. It shows the rate of change when we would increase x by 1 unit. So let's say we would go from x to a value larger than x, right? Let's say that that would be an increase in x. Well, if that was our x, let's say that we increase x by h units. Let's call this h. This whole difference over here, that would be our h. So we increase x by h. That would be the difference in x. Now, how does our function change? How do we go from f of x, so this is f of x, the corresponding y value of x, and the value that we're reaching is f of x plus h. F of x plus h. F of x plus h. Now look, I think this will ring a bell. What do we have here? We have a rate of change. What is the rate of change? It's a slope. What is a slope? It is delta y over delta x. Okay, what is delta y and what is delta x in our case? Well, remember, delta y is the rate of change between the final point and the initial point. We are getting to this point of f of x plus h, f of x plus h, and we started at this point over here, which is just f of x. We started at f of x. And what is delta x? Well, delta x is the final point, which is x plus h, this point over here, minus the initial point where we started at x, minus x. Well, let's do some math. F of x plus h minus f of x divided by x and x cancel out, this x and this x cancel out, divided by h. Do you see what we mean here? Why this would be a limit? Here and here, these are the same things. And now let's actually prove what is this limit of h approaching 0. You see, we said that the derivative would be the rate of change when x increases by 1 unit. And this 1 unit, well, we just show it as an h. But that would be the rate of change of 1 unit when x changes by 1 unit. Or if we want to say a different unit, let's say 2 units, 3 units, x changes by something. That something is our h. But we want to know the rate of change exactly at this point. We call it instantaneous rate of change. So what is the rate of change exactly at this point? Well, we want to change x by a very, very small amount. We want to move x just a bit to see how our y changes. Well, if we want to move x just by a bit, our value, our change in x is going to be very, very small. It's going to be 0.000 something. Well, that 0.00 something is h approaching 0. That's why we call it as a limit of h approaching 0. When the change in x is so small, what is the change of what? That is the derivative. That's why we're actually taking the limit of this slope as h approaches 0. I hope that makes sense. And now with this in mind, let's actually apply it to our 1 over x. So how can we prove the derivative of 1 over x? Well, remember, the derivative would be, let's write it once again, the limit as h approaches 0 of f of x plus h minus f of x divided by h, divided by the change in x. Well, that would be the limit as h approaches 0. What is f of x plus h? Remember, if f of x is 1 over x, let's write it like that. If f of x is 1 over x, this thing is 1 over x, well, f of x plus h should be 1 over x plus h, because instead of x in our input we have plus h, so we're adding plus h in our input, minus f of x, we just said, is 1 over x, because that is the function that we're differentiating, divided by h. Okay, we have a subtraction with different denominators. Let's make it common. Let's take the common denominators. So let's multiply x plus h times x. Let's multiply x with x plus h. So we would have the limit as h approaches 0, and here we have 1 times x is just x, divided by x times x plus h. That's our denominator, minus 1 times x plus h, so minus x plus h. Keep the brackets always, because the negative sign is going to affect the sign inside the bracket, divided by x times x plus h, everything divided by h. Okay, it's getting better. Let's move on. Change colors real quick. So because we have the same denominator, x times x plus h, on both sides, well, let's write it as a common fraction. So we would have the limit as h approaches 0, x minus x plus h, after we open the brackets, would be x minus h, because the negative sign changes the positive sign, divided by x times x plus h, everything divided by h. Okay, that's equal to the limit as h approaches 0. X minus x cancels out, so x and x cancels out, when we're left with minus h divided by x times x plus h, everything divided by h. Okay, what does it mean to divide everything by h? It means to multiply with the inverse. So we have limit as h approaches 0, and here we have minus h divided by x times x plus h, multiplied with the inverse, with 1 over h. That's literally what the division means. So h and h cancels out, so h and h cancels out, and we're left with the limit as h approaches 0, minus 1 divided by x times x plus h. Okay, that's our final step. Let's substitute 0 into h. Well, if we substitute 0 into h, because that's what we're doing, we're taking the limit as h approaches 0. So if h would be very close to 0, what would be this whole value? Well, we would have minus 1 divided by x times x plus 0. So that would be minus 1 divided by x times x, which is minus 1 over x squared. That would be the derivative of 1 over x using this formula. Now let's check it with our power rule. Let's go to this side and check it with our power rule. If we would use our power rule, what is 1 over x? 1 over x is equal to x to the power of minus 1. If we take x to the power of minus 1 derivative, well, remember, we take the power in front times x to the power of minus 1 minus 1. And that's equal to minus 1 times x to the power of minus 2, which is equal to minus 1 divided by x squared. Do we see the same result? Here and here. Same result, two different methods. But it's very wise to understand the graph with this limit, because that's literally the best explanation for the derivative. The derivative is this limit when our change in x approaches 0. When our change in x is very, very small, so we can see how the function instantaneously changes. I hope this makes sense. We are done.